Today's learning targets. Okay, I can manipulate complex numbers. That is represented by I. Remember, I is for imaginary numbers. Right? And I can find complex roots, zeros, and solutions. All right? As I said before, it's very algebraic today, which is nice, and we don't got to worry about certain rules and abstract thinking. It's just math. So, first let's determine what a complex number is. Okay? The definition is any number or numbers that can be represented in A plus BI form. Now, A is a regular number, B is a regular number, and then they have that I there for imaginary. So this could be 2 plus 3I. It could be 6 minus 11I, whatever. But the first number, the letter A is a number, that comes first. And the letter B, the number with the I, comes second. Okay, that's kind of standard form. Like we write a quadratic, we write the x squared first, then the x. This is considered standard form for complex numbers. All right, so let's write the polynomial function in a standard form and identify the zeros of the function and the x-intercepts. Well, I tell you what, we're going to be able to do this, the zeros, and the x-intercepts really without doing any math, just by looking at it. All right. The only place math is going to come into play is when we got to get the polynomial function. All right. So first, if I ever wanted to find the zeros, the x-intercepts, the solutions, the same thing of a quadratic, why don't we have to factor it and then t-bone it and those the answers? Well, it's already factored. All we got to do is t-bone this. Right. So if I t-bone this. What's this answer here? X would equal what? Yeah, it would be a positive 2i, right? And this would be a negative 2i, okay? Those are the zeros. That's done right there. Now, what did I say I stood for? What word? Imaginary. So, aren't the zeros also the same place as the x-intercept? But if it's imaginary, you think it's really going to touch the x-intercept? No, it's not real, it's imaginary, so it won't really touch the x-intercept. So are there any x-intercepts here? Are there any zeros that aren't imaginary? No, they're both imaginary, right? There are none. So that means if I were to graph this, it would be one of those graphs that never touches the x-axis, right? So we have our zeros, we have our x-intercepts, and again, to get the zeros, we really just flip these signs, didn't we? No math. To get the x-intercepts, well, it's the zeros that are real, are not imaginary. There have to be numbers here. No math whatsoever. Here's where the math comes into play. If I want to write the polynomial before its factored form, I'm going to have to FOIL that. Okay, I'm just going to rewrite this here quickly. I'm going to have to FOIL this. And let's go. What happens when I multiply x times x squared? Okay? What is x times a positive 2i? Consider I like another variable in this case. So if that was 2y, it would be 2yx. In this case, we'll call it 2ix. Or the way we write it is the I always comes last. We say 2x. Alright? Now, what happens when I take a negative 2i times x? Negative 2x. And last, but certainly not least, this is pretty important. Okay, I have a negative 2i times a positive 2i. Again, think of the I as a variable. What would it be if that was 2y and 2i? That was a negative 2i and 2i. Yeah, it would be negative 4, and then I times I is I squared. Now let's clean this up, shall we? Yeah, the middle terms cancel. These cancel, that's beautiful. Those imaginary go away. So I've got x squared, but I still have an imaginary number here. Does anybody remember? Yeah, yes. So that good, Miguel, good. So I is actually radical negative 1. If I square I, What happens when I square here? Don't these cancel? So we are going to actually replace this with a -1. So if you need to in your notes, if you don't remember, you definitely need this. This is going to get rid of a lot of i's. So we'll get rid of a lot of i's. Yeah, I to the third power would be just negative I, we call it. Then I to the fourth power, I think it's 1. No, it actually goes to the third. It was 0. I to the 0, I to 1, I to 2, I to 3, and then just cycles through those same 4. So I to the 0, anything is 1. The I is radical -1. I squared is -1, and I to the third would be negative I. All right, so what's going to happen here? What's going to happen when I multiply -4 times -1? +4. That's my original polynomial right there. That is my original polynomial right there. So, based on the information we got before we FOIL that, we said there's not going to be any x-intercept as such. Let's graph that and find out. Oh, I hate this. Let's take that. Bam. 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 Large screen. Y equals. Clear this out. We got x squared plus 4. And I'm going to make sure that my window is 10 by 10 it is. And when I graph that, there you go. This is our x-axis. This is our x-axis. But since it's x squared, should we have 2 roots, right? Because the biggest exponent is 2. It's a degree 2. Well, they're imaginary. That's why they don't touch. So anytime it doesn't touch, it's like, well, there's no x-intercept. There isn't. But they have imaginary. We should have 2. It's imaginary. Like, for example, if I were to have an x cubed, doesn't x cubed kind of go like this? If I had a funky one, that went kind of like this and kind of came down like that, well, I might have one real root at -6 here, but I have 2 imaginary roots, okay? Which means 1 would touch, and the 2 would difference of your imagination, right? So here we go. Let's try this. Let's take it a step forward. Without doing any work, tell me what the zero, who can tell me what the zeros would be right now, without even doing work? Well, equals 5, right? We're going to T-bone this. So x would equal 5. X would equal, yes. Now this I is outside the radical. We always do the number first. It's radical 2, and then it's I like that. And what's this one? Yeah, that's it. Those are the zeros. Done. And out of those zeros, which ones are actual x-intercepts? 5. That's the only real number there. So that's the only real spot that's going to be touching at the x-intercept. All right? Our x-intercept is 5. Our zeros are 5, and there's radical 2i and negative radical 2i. All right, done. We answered the majority of that question right here. Yes, you can. But you can have in this problem, because when we FOIL it together, don't we have 3 x's? So it should be x cubed. So you can have 3, you can have 2, you can have 1. In this case, we're only going to have 1. Now, rest of the polynomial, you're going to have to FOIL things together. And I will give you a bit of advice. I'll let you guys do this in a second. I would, I'm just going to rewrite these. You got x minus 5, x minus radical 2 times I. That I is not in the radical. It makes a difference. It's x plus radical 2. Now, I would FOIL these two together first. How come? Yeah, that's a difference of perfect squares. They're conjugates, right? The middle sign changes. Just like the previous problem, the middle sign was different, wasn't it? The minus, and what happened? The middle terms canceled. So I ended up still with 2 terms. So when I do this and I see, oh, these are conjugates, the middle signs here are different, I should start there because the middle term is going to cancel. All right? And then when you get that, then you distribute that with your x minus 5. It'll make life easy. I'll give you what you got. All right, so let's FOIL the first 2 on the right here. When we FOIL these, what's x times x? X squared. X times a positive radical 2i. will be plus what? Radical 2, and then we put the x before the I. Remember, the I is not under the radical. Okay, and now we're going to do the same thing here, but now it's a negative radical 2i, so we just get minus radical 2xi. And what's the last thing? What is the negative radical 2i times a positive radical 2i? It is a negative, it's a negative value. What is radical 2 times radical 2? Radical 4. What's the square root of 4? 2. Remember, whenever I multiply anything under the radical by itself, the radical goes away and just becomes that number. So it just becomes 2. Now what about the i's? I squared. Yes, 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 yes. So before I even start the formulas into the next one, let's clean it up. Shall we? The positive and negative terms in the middle will cancel. This I squared becomes a negative 1. So now I've got x squared. Negative 2 times negative 1? Positive 2. And I'm going to multiply that times x minus 5. Alright? Let's do this. X times x squared. Yes, x to the third, thank you. Alright? X times 2. That's just 2x. Alright? Negative 5 times x squared. Yeah, negative 5x squared. And a negative 5 times a positive 2 is negative 10. I'm just going to clean this up and write it in standard form because I believe the problem asks me standard form, which means the exponents should go from biggest to smallest. You got it. And that's my calculus. So if I graph this, if we graph this, how many times is it going to touch the x-axis? Once. Once. We have 3 zeros. But they actually touch 1 at 5 because my other 2 are imaginary. It won't touch there. Let's practice. Let's practice. So I'm going to go erase my imaginary so we don't need that anymore. And I'm going to go to calculator, go to y equals, clear, and I've got x cubed. Move out there. Minus 5x squared plus 2x. Minus 10. And if I graph this right, it'll touch once at x equals 5, correct? Bang, right there. And then it goes up and does something and keeps on going up. Because remember, it goes down, does something, I don't know, and then it goes up. Right here, at 5, no other place, we nail it. There's nothing better in all of math when you start to deal with stuff like this. You know, imaginary numbers gives a little bit more writing than we're used to solve a problem. But we do it 100% correctly, and a computer does it, and they do it the same way you do it. No better feeling in the world. Well, in math. All right, next one, number 3, write the polynomial function in standard form and identify the zeros of the functions and the x-intercepts. So, what are my zeros? X equals 3. What do I hear? Negative 3. X equals, oh, they're 3. They're both minus. They're both be plus. What do I hear? X would equal I. X equals negative I. These are my zeros. Done. What about, what's my x-intercept? 3. It's one spot, 3. I don't have to write 3 twice. I just have to write it once. And it will still touch 3 one time. Do you remember what we called that? I mean, it's a couple weeks ago when the situation like this, it was 3 with a multiplicity of 2. Remember that? We don't have to, I mean, you don't have to know this for the problem. I'm just trying to bring in stuff we've learned before. So if I see, well, x-intercept is 3 with a multiplicity of 2, when I go back and try and get my main function, I start to FOIL everything out again, I need to know that I have to do this twice. That's all that multiplicity does. Okay? That's not necessary for the answer here. You just need the x-intercept, which is 3. Here are your zeros. Now, when it comes to foiling, this here you should probably do first because that's a difference of perfect squares, middle terms of cancel. But I want to show you something about the 2 on the left here. Okay? I want you guys, here's a shortcut. I know you probably FOIL it, you do the 2 arrows, you distribute the x twice, you distribute the negative 3 twice left. let's remember where this came from. All right? I know that a quadratic was x squared, correct? This is how I do it quickly up here. So if you guys can start doing this quickly, it'll save you time as well. And I'm going to show you how I do it. All right? When I'm doing something, it's plus or minus some another term, x, right? Plus or minus some number, I don't know. Isn't these two numbers need to add to this middle term and multiply to the last term? You know what I'm talking about? Like if I had just the quadratic and I had to get here, I need to find these two numbers that should add to the middle term and multiply to the last. So that's just what I do with them. Why don't I add -3 and -3? What does that give me? So guess what? Bam. Why don't I multiply -3 and -3? What's that give me? And that's it. You don't have to FOIL or combine or anything. You see what I'm saying? That to me, that's a lot easier. But you gotta understand how it works. Okay, well I add these two numbers for the middle term. I multiply the two numbers for the last term. Okay, well instead of FOILing it, I know it's going to be, why don't I just add them and put that in the middle and multiply and put that in the back? That's a nice one. So that, yeah, I knew you guys would. So that is the first, now you just gotta FOIL this. The middle terms are canceled, you have the I squared into that, and then FOIL that into your quadratic. So we have one more step. So you guys finish that, there you go. All right, so what did we get when we FOILed our back to? What was the end product of just those? X squared, and what do we get? -1? All right, let's see if she's right. X times X gives me X squared. X times I, well, that's plus XI. X times a negative I is minus XI, they cancel. Then I get a negative I squared. Okay? Yeah, these two middle terms cancel, and what happens at the end? It's possible, very good. Because when you end up with this, don't forget the -1 just goes in for the I squared. So you have a minus a -1, which, yes, turns to a positive 1, which means this just turns to a +1. Okay? X turns to a +1. If it was a -1 here, I want to factor it, I get answers 1 and -1. I want to get I and negative I. They get real numbers. Okay? So, let's FOIL this. Okay? Now, a lot of people see this and like, oh, that's not 2 by 2. Come on. But let's look at this in reality. When I multiply anything by x squared, all I'm doing, I'm not changing the number in front, the coefficient. I'm just changing the exponent and raising it by 2, right? I'm adding 2 more x's. So x squared becomes x to the 4th, right? -6x, well, that stays -6, so it's x cubed. And I have a 9, well, that's plus 9x squared, because there were no x's. That's it. I just FOILed my x squared into there. Now I've got to put the 1. What happens when I multiply anything times 1? It's the same, so really it's no work. I've got 1 times x squared, that's x squared. I'm going to line my x squareds up together, just so when I add them, they're all nice. Okay. 1 times a -6x, -6x. 1 times 9 is plus 9. Now the only thing that I can combine here is this right here. So I've got x to the 4th minus 6x cubed plus 10x squared minus 6x plus 9. That is my main function. And now, we said when we graph that, we've got 4 zeros. 3, it happens twice. I and negative I. But in reality, our x-intercepts, how many are there? There's 1 at 3. So if I were to graph this, that's just once. And x equals 3, right? So we'll clear this out. We've got x to the 4th. Wow, x to the 4th. Bam. Minus 6x cubed. Bam. Plus 10x squared. Minus 6x plus 9. That's 30. Let's graph it. And there it is. There it is. There it is. This looks, because it's an even, it's going to be like a parabola. It either goes up forever on both sides or down forever. This has to go up forever. Can't see it here. In case you couldn't see it comes down, there's this little funky thing. Touches once right there, comes up. That happens to be right at 3. I like doing work that's a little bit more difficult than easy stuff, and having it perfect. There's nothing better. Nothing better than that, guys.